In question 2, the first question asks us to find the inverse of this 3 by 3 matrix. So at first we'll find the determinant of this matrix M. To find the determinant, I do 2 times the determinant of this matrix, of this 2 by 2 matrix, by cancelling out the row and column that 2 is in. So this part only. Then I move to the next value. So I do plus 0 times, I don't need to even calculate since it's 0, but for other matrices where you don't have 0 for this, you can do this. And then for the final one, you have 0 times the determinant of 0, 1, 3 minus 2. So this is just 2 times. For the 2 by 2 matrix, you have AD, so 1 into minus 3 minus BC, which is this, 4 times minus 2. So this is 2 times minus 3 plus 8. So 2 times 5, which is 10. This is the determinant of M. Now I want to find the minor matrix of M. So the minor would be, for 1, 1, we'll have the determinant of this, which is 5. It's just 1 times 3. Wait, it's minus 3. So 1 times minus 3 minus 4 into minus 2. This is minus 3 plus 8, which is 5. We have already done this. That's for 1, 1. Now for 1, 2, which is row 1, column 2, this entry, we have to find the determinant of this matrix, 0, 3, 4 minus 3. This comes out to be 0 times minus 3 minus 4 into 3, which is minus 12. Then for the entry 1, 3, row 1, column 3, this one, we do the determinant of 0, 1, 3 minus 2. The determinant is minus 3. 0 times minus 2 minus 3 times 1. Then moving on to the second row, I'll do the same. For the 2, 1 entry, it's the determinant of 0, 0 minus 2 minus 3. It's just 0. Then for the 2, 2 entry, it's the determinant of 2, 0, 3 minus 3. 2 times minus 3 is minus 6. 3 times 0 is 0. So this is minus 6 minus 0, minus 6. Then for this entry, 2, 3, I get the determinant of 2, 0, 3 minus 2. 2 times minus 2 is minus 4, and that's the determinant. Now moving on to the third row, we had 0 here. The 3, 1 entry is the determinant of this matrix, which is 0 times 4 minus 1 times 0. So it's just 0. Then it's this. So 2, 0, 0, 4, 8 is the determinant. And finally, we have the 3, 3 entry. It's the determinant of 2, 0, 0, 1. It's just 2. This is the minor. Now for the cofactor matrix, we do this. So we multiply a -1 on this 4 values. It's all the values where the I plus j, so, or the row number plus the column number adds up to something that's odd. So if I look here, this is row 1 column 1. If you add them, you get 2. For this, the minus, you have row 1 column 2, 3. This is odd, so this is a minus. This one is 1 comma 3, so 1 plus 3 is 4, and so on. You just need to remember that this 4 values, this, and this are negative, so the cofactor is 5. 5 remains the same. Minus 12 becomes plus 12. Minus 3 remains the same. 0 remains 0. Minus 6 remains minus 6. Minus 4 becomes positive 4. 0 stays 0. This 8 becomes minus 8. And this 2 remains the same. This is the cofactor matrix. And now the final step to find the inverse is just multiply the determinant, which is 10, or 1, the inverse of the determinant. So it's 1 by determinant of m times the cofactor matrix. This turns out to be 1 by 10 times this matrix over here, 5 zeros, 12 minus 6. This is the answer to part A. Now in part B, we are told that the transformation by AM maps the plane pi 1 to plane pi 2, and the point xyz in pi 1 maps to uvw on the plane pi 2. We have to find x, y, and z in terms of uv and w. And we are so if I multiply x, y, z with m, I get uvw. Now since we already know m inverse, we have two approaches to this. We want our x, y, and z in terms of uv and w, so alpha u plus beta v plus gamma w. So in this form you want your representation of x, y, and z. If you multiply the matrix M over here, you'll get additional terms with x that you have to swap back. This is a valid answer as well, but I'd prefer doing the other way around. You know that M times x, y, z is uvw. So you can multiply M inverse on the front of both of them on the left. So M inverse on the left on both sides. M inverse becomes the identity matrix times x, y, z equals to M inverse u, v, w. The identity matrix times x, y, z just leaves you with x, y, z, and this is equal to M inverse u, v, w. Now, if you are not confident with your answer to M inverse, you can still save your marks using this one. Just find this, and so if you get 2x, 3y, 4z equals to u, v, w, just solve them like this. Solve them and make x, y, and z the subject, and then give your answer. It will take more time, but it's gonna give you the right answer as well. But now if we continue in this approach, we know the value of M inverse over here. It's this. So x, y, z is equal to 1/10 5 0, 0, 12 minus 6 minus 8 minus 3, 4, 2, and UVW here. Now we just do matrix multiplication. We are multiplying a 3 by 3 matrix with a 3 by 1 matrix. So what we get back is a 3 by 1 matrix. These two values need to be the same. So the column number of the first and the row number of the second, because we multiply in this way. So 5, we had 5 times u plus, so 5 times u plus 0 times v times 0 times w. On the next row we do 12 times u minus 6 times v minus 8 times w. In the last row we do minus 3 times u plus 4 times v plus 2 times w. So x, y, z is 1 by 10 times 5u, 12u minus 6. I can just put the 1 by 10 inside already. 5 by 10 is 0.5u. For this I have 1.2u minus 0.6v minus 0.8w, and for the last line I have 0.3u plus 0.4v plus 0.2w. So x is 0.5u, y is 1.2u minus 0.6v minus 0.8w, and z is minus 0.3u plus 0.4v plus 0.2w. Now in the last question we are given the equation of plane lambda 1 or pi 1, and we need to find the Cartesian equation for plane pi 2. So the equation is 3x minus 7y plus 2z equals to 0. Sorry, it's equal to minus 3. Since we already know the representation of x, y, z in terms of u, v and w, I'll just substitute those in. So 3 times 0.5u minus 7 times 1.2u minus 0.6v minus 0.8w plus 2 times minus 0.3u plus 0.4v plus 0.2w is equal to minus 3. So I have 1.5u minus 8.4u plus 4.2v plus 5.6w minus 0.6u plus 0.8v plus 0.4w equals to minus 3. If I add the u's together, 1.5 minus 8.4 minus 0.6, I get minus 7.5u. Then if I add the v's together, we have 4.2 and 0.8. This adds up to 5v. And adding the w's together, 5.6 and 0.4, I'll get 6w. This is equal to minus 3. Since I want to keep it in integer multiples, I'll multiply both sides with 2. I'll be left with minus 15u plus 10v plus 12w equals to minus 6. This is the equation of plane pi 2. And that's it for this question.